Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 10G. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GRS Scholastic LLP, it's my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and yesterday, that is 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. This is a kind request to all the participants to kindly adhere to the timeline so that we do not exceed the session. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chairs for this session, Dr. Pankaj Chandra and Dr. S. Radha. Dr. Pankaj Chandra is an associate professor in the Department of Computer Science and Engineering at MIT ADT University, Pune, India. He has published over 60 papers in international journals and conferences. His research interests include network security and information security, contributing to advancements in cybersecurity and secure computing systems. Thank you so much for joining us, sir. I kindly request you to deliver the welcome remark and set the tone for the session. Okay, I think there's some network error. He has left. So will be joining us again. Meanwhile, we have another chair with us, Dr. S. Radha. Dr. S. Radha is an associate professor at Chaitanya Bharati Institute of Technology, CBIT, Hyderabad, India. Her expertise lies in biomedical engineering and communication engineering, with a strong focus on research and innovation in these fields. Through her academic contributions, she aims to advance technological solutions that bridge healthcare and communication systems. Thank you so much, ma'am, for joining us. I request you to kindly deliver the welcome remark and set the tone for the session. You're on mute.
Sorry.
Yes.
I welcome all the participants to the 9th International Conference on Information and Communication Technology for Intelligent Systems. I wish all the best to all the participants. We'll start the session. Thank you.
Thank you so much, ma'am. Thank you so much. So without further ado, let's begin this session. Uh, Anisha, can you just go to the next slide? Yes. First up, I would like to invite Jeff and Sunny to kindly present his paper titled A Study on the Impact of AI-Driven Nudges on Financial Wealth. Do we have you here with us, Jeffin? Are any of the team members present? All right, since no one from the team is there, we will be moving forward. I request Anju Devi to kindly present her paper titled An Optimized UAV-Based System for Intelligent, Safe, and Cost-Effective Coconut Harvesting. Do we have you here with us, Ms. Anju?
Hello, am I audible?
Yes, ma'am, you're audible.
Okay,
Can you
thanks.
kindly share your screen?
Yeah, sure. I guess my screen is visible.
Yes, your screen is visible.
Okay, thank you.
Uh,
Yeah.
yes, you may start.
Okay. So, good evening to all respected members of the session. It's an honor to be here at ICTIS 2025. Myself, Anju Devi, a research scholar from St. Kitts College of Engineering, India, and I'm here to present a work titled An Optimized UAV-based System for Intelligent, Safe, and Cost-Effective Coconut Harvesting. Our primary motivation for this work stems from the pressing need for innovation in agricultural automation, especially in the area of coconut harvesting, which continues to rely heavily on manual labor. So today I'll walk you through how our UAV-based solution integrated with AI and labor technology provides a novel approach to tackle labor shortages, safety concerns, and productivity issues in the domain. So moving on to the tables of contents, here's a brief overview of the presentation flow. We will begin with the introduction and the literature review, followed by the objective of the study. Then I will walk you through the proposed system overview and the detailed system architecture. We will review the results and discussion, highlight some challenges and the future work, and finally conclude the presentation. So let's now begin with the introduction. Coconut harvesting, especially in tropical regions like Kerala, is still largely dependent on skilled manual climbers. However, in recent years, the sector has faced a growing shortage of labor coupled with risk and physical strain involved in climbing tall trees. So, this situation has significantly impacted the productivity and efficiency of coconut harvesting. With the rapid growth of automation in agriculture, there's a promising opportunity to develop solutions that reduce dependence on manual labor while enhancing safety. In this context, our research presents a novel UAV-based harvesting system that incorporates image processing and machine learning for autonomous and intelligent operations. Now, let's move on to the literature review. Traditional coconut harvesting methods have long been recognized as both time-consuming and potential hazardous, especially due to the height and physical risk involved. Several prior automation efforts have been made in this space, ranging from robotic arms to semi-autonomous ground workers. While they show potential, they often face mobility limitations and are not fully scalable in real-world farming environments. Interestingly, only a few studies have explored the use of aerial platforms such as UAVs or harvesting purposes. And even those are often limited in intelligence and precision. What most existing systems lack is a tight interaction of a system of smart detection algorithms with accurate cutting mechanisms. So in contrast, our approach includes a comprehensive solution by integrating UAVs with artificial intelligence and laser technology, allowing for both intelligent target identification and precise cutting, thereby improving efficiency and safety. Moving on to the objective. The primary objective of our research is to design and develop a drone-based system that can autonomously identify and harvest mature coconuts from trees. We aim to achieve this by employing image processing and machine learning, identifying image processing and machine learning and techniques to accurately detect the right coconuts amidst dense foliage. Additionally, we integrate a laser cutting mechanism for safe and efficient detachment, reducing the risk of damage to both the fruit and the tree. Ultimately, our goal is to minimize human intervention, address the growing labor shortage, enhance harvesting efficiency through automation. Now, the proposed system overview. So here's a step-by-step overview of our proposed UAV-based harvesting system. Initially, the UAV navigates autonomously using GPS waypoints to approach the over near the coconut tree. Then an onboard high-resolution camera captures detailed images of the tree crown. These images are then processed by a machine learning model trained to accurately detect mature coconuts based on visual features such as size, color, and position. Once a target is identified, the UAV intelligently repositions itself and activates an integrated laser cutting mechanism to precisely serve the coconut stem. Finally, the harvested coconut falls safely into a predefined collection area, minimizes damages, and ensuring an efficient harvest. So moving on to the system architecture, the architecture of our system is designed to ensure real-time communication, autonomous control, and safe harvesting through both aerial and ground components. At the core is the telemetry module you can see in this figure. which continuously collects vital data such as coordinates, altitudes, and UAV status. The data is transmitted to a ground station transmitter or receiver, and which establishes bidirectional communication between the UAV and the operator. An external antenna is used to strengthen the wireless link, ensuring uninterrupted data flow even at various altitudes or longer ranges. The ground control station serves as the operator's interface, allowing for manual override, monitoring, and mission planning if required. An important addition to our design is the soft landing system, which addresses post-harbor safety. It includes two key components. That is, the first, the soft landing monitor, which manages the timing and then aligned of the drop-based UAV of position. Second, the soft landing surface, which is either cushioned or netted, ensuring the harvested coconuts land gently without any damage. Moving on, so there are hardware and software components. The system integrates both hardware and software components to enable real-time autonomous coconut harvesting. On the hardware side, we use UAV with the GPS, IMU, and stabilized gimbal, along with a Raspberry Pi, a high-resolution camera, and a laser cutting unit. The software stack includes Python OpenCV TensorFlow, which together handle image processing, detection, and control functions. Our ML model is deployed on the edge, ensuring quick detection without needing cloud access. Moving on, for component detection, use the YOLO V11 object detection model, known for its speed and accuracy in real-time applications. Input images were pre-processed through cropping and noise reduction to improve detection performance. Training with a drone using a custom dataset, which include annotated images of coconuts from various angles and light conditions. The models show high detection accuracy during both simulation and real-world testing, making it well suited for autonomous harvesting. The laser cutting mechanism. Our proposed system includes a laser cutting unit for detaching mature coconuts in a precise and non-contact manner. Laser technology is chosen for its accuracy, minimal mechanical complexity, and reduced wear compared to traditional cutters. So the implementation is in ongoing process. This module holds significant potential to simplify the harvesting process by replacing complex mechanical systems. Now, the results and discussion. In our lab testing, the coconut detection algorithm using the YOLO V11 model achieved an accuracy of over 90%, demonstrating strong performance even in verified lighting and background conditions. We also observed a significant reduction in time per coconut compared to traditional manual harvesting, highlighting the potential for operational efficiency. While the laser cutting module is still under development, our initial simulation trials and control tests indicate that it can effectively cut coconut stems without causing damage to any surrounding areas. So these results are promising and form a strong foundation for scaling the system into real-time autonomous field deployments. Next, let's discuss about the advantages. The system is faster than manual harvesting, ensures safety by avoiding human climbing, and scalable for large plantations. It's also cost-effective over time by reducing labor needs and eco-friendly with the low noise and zero emissions. Now, despite promising results, we face a few key challenges. One major issue is the payload balancing, as the onboarding laser and camera add significant weight to the UAV. We are also limited by battery life, which affect long-term field operations and environmental factors like wind and lighting conditions, and that can reduce accuracy. Additionally, the ability of high-power laser modules suited for clean cutting is limited and costly, which poses a hurdle for real-time deployment. Now, looking forward, we aim to explore solar-powered UAVs, then implement swarm-based harvesting, and design a real-time feedback loop for adaptive controls. To conclude, our research introduces a novel UAV-based system designed for autonomous coconut harvesting. By integrating AI-powered detection and a laser cutting mechanism, the system ensures both precise and safety. Our approach not only addresses the shortage of skilled labor, but also a cost-effective, efficient, and scalable alternative to traditional methods. Overall, the system represents a significant step forward in smart agriculture, especially in enhancing productivity and supporting rural innovation through technology. So, These are some of the key references that supported and guided our research. And so thank you all for your time and attention. We hope our work contributes to meaningful to the growing field of smart agriculture. We look forward to your questions, suggestions, and feedback that can help us improve and take the research further. Thank you.
Thank you, Anju. Are there any questions?
Is it in prototype, as of now, it is in prototype model or in real existence?
Ma'am, it is in prototype model. Since the laser cutting mechanism is a little bit difficult for us because it's we know that most of the high-end lasers are not at all available every time. So we need a lot of license and all. So it's in prototype model. We are trying to make a minimized model
And
and apply for future fundings if it possible.
Okay, and about battery life, what is your expectation? Battery life.
Okay. For battery life,
how many coconuts each it can support in cutting? Number of days or number of coconuts or?
Ma'am, power battery that's power is managed using some dual battery system. So when the UAVs flight, the navigation are powered separately from the laser to avoid sudden drains. So we are also exploring lightweight, ultra capacitors and efficient battery technologies to extend the flight time.
Okay, that is okay. But how many coconuts it can be cut? That's the point. Means
Okay, ma'am, we are expecting to cut 3 to 4 coconuts at a time. But since the model is on the prototype stage,
yes.
it's only under expectation.
Okay. Okay, no more questions. Thank you. Nice presentation.
Thank you, ma'am. Thank you so much.
Thank you so much, Anju.
Thank you.
Right. Moving forward, I would like to invite Shashikala to kindly present her paper titled Intelligent Load Demand Allocation, a Markov Chain Approach, Integrating Peer-to-Peer Energy Markets. Do we have you here with us?
Yes.
All right. I'll stop presenting so that you can share your screen.
Can I share my presentation?
Yes, please.
Okay, good afternoon all. I'm Sasikala from the Department of Electrical and Computer Engineering, the Open University of Sri Lanka. Our paper, Intelligent Load Demand Allocation, a Markov Chain Approach Integrating Peer-to-Peer Energy Markets. Let's move to the introduction. These are the content of today's presentation. Sorry. Yes, let's move to the introduction. With the depletion of non-renewable energy sources such as coal, oil, and natural gases, and with the environmental impact of high level of carbon emissions of those conventional energy sources, and the integration of technical and policy improvement in the global market, which enhances the emergence of renewable energy sources. With this enhancement of REAs into the global scenario, we have a lot of energy in the customers, those who have solar PV and the battery energy storage in their premises. With this excess energy, of course, there should be a market options to trade this excess energy. And in traditional way, we have the grid to trade with the grid. And also there are new emerging markets available trading with another market, which we call the peer-to-peer energy trading. Peer-to-peer energy trading is a new concept which allows traditional electricity consumers to become prosumers and actively participate in energy trading in the utility microgrid. And also it allows energy exchange between neighbors so that it maximizes the benefits of all the participants in the peer-to-peer trading throughout the network. And also more distributed generations can be integrated to the existing system under this new trading paradigm, so that there will be dedicated devices, infrastructure, and associated information system platforms are there to support the P2P trading. In this P2P trading happen in both two layers. One is the physical layer, which connected all the physical infrastructure such as grid connection, smart metering connections, and all the communication infrastructure. Under that, there will be a virtual layer on that to maintain the information system securities, and the market operation and the pricing mechanism could be integrated into the virtual layer platform. So there we have different P2P structures in the world: fully decentralized, community-based, and hybrids. There will be different architectures in all of those decentralized, community-based, and hybrid markets. Since there are two layers to be maintained, there will be a challenges, technical challenges, security challenges, and operational challenges. So let's move to the literature part. In the literature, there are a lot of papers are there in the P2P trading, because this is a new technique, new technology. Technical challenges in the grid integration, and there are regulatory and policy challenges, and there are literature on economic and market challenges and real-world complexities. When we divided these literatures into the different section, one key section identified is the prosumer behavior and the preferences in peer-to-peer energy trading when there is prosumers with solar PV and battery energy storage. Mainly the prosumer behavior and preferences, again, there is a key correlation between dynamic pricing and the battery energy storage management. So therefore, the research in this research, my research is focused on the prosumer behavior and the preferences. The research gap is existed because there is a lack of comprehensive economic model that integrate prosumer behavior and the dynamic pricing with the technical limitation of the customer-owned resources such as the battery energy storage system. So therefore, to address this gap, it requires the development of new framework that incentivize prosumer participation while considering the maximum benefits to the prosumer. So the objective of this study is to develop a peer-to-peer energy trading model that identifies the maximum cost benefit option for all prosumers participating in energy trading for a given moment. So therefore, let's move to the methodology. In this methodology, based on the developmental model, which integrate new techniques to the existing load demand allocation for the single prosumer, that means for a single participant in the P2P trading. So therefore, we need to identify the parameters associated with each agents and identify the mathematical formulation through the development of the transaction model, and design and develop simulation model, test and verify the simulation for different scenarios, and analyze the scenarios for external parameter variation. Those are the main key steps in the methodology. Let's move to the develop single prosumer load sharing model, which is the main key component in the methodology. That is done through the use of multiple segment Markov chain model. Then segmented Markov chain for energy sharing in the peer market environment, which include two distinct key elements. One is to define elements of transition probability matrix based on prosumer decision flow diagram. Another thing is to determine different transition probability matrices for each time segment. This is the modeling of the our system. Each for a particular household, there could be 4 different energy sources that can be used to supply his load demand. One is the solar PV, battery storage, peer-to-peer energy market, and grid supply. Energy distribution among these resources depend on the state of each these energy agents and the influence of external and internal parameters. Therefore, the state variables are selected such as, for the each elements, the states variable are selected as SOC, the grid price, and the market price, that means P2P market price, and the market available power or energy as the state variable. With this variable, discrete time Markov chain can be integrated into a model to model the single prosumer, where the prosumer represented by the discrete time Markov chain model, where each status represents one of the energy mode. and the transition from present state to the next state only depend on the present states of the energy sharing, but not the past data. That's why we use the Markov chain modeling integrated into model this prosumer. So Markov model can be represented as xm plus 1, that is represent the next state, integrated with the transition probability matrix P multiplied by the xm, that means it represent the present state. So therefore, it only depend on the next state data is only depending on the present state, but not the past data. So the key aspect of this process is to identify this P matrix, that is Markov transition probability matrix. So here it represents the Markov transition probability matrix, 4x4 matrix. There are 16 elements. As here it shows off diagonal element indicate the shifting from one energy mode, which means solar, battery, market, and grid, to the energy mode over time. The diagonal element shows the probability of remaining in the same energy mode over time. With this with the time, the variables are the parameters of external variables are changing. Therefore, the elements are changing with the time. So, to determine the Markov transition probability matrix, this the prosumer decision flow diagram is driven, so that based on this flow diagram, we define that 16 Markov transition probability matrix elements. So it was assumed that least cost occurred for the prosumer when taking energy from his battery. So rather imports energy from the market to grid. And also market price is considered as the pool price. These are the equations that we derived based on this flow diagram to identify the each elements of the transition probability matrix. Based on the external and internal parameters of these equations, the values of the transition probability matrices vary in different time segments throughout the day. Therefore, there could be this kind of 16 elements. With these 16 elements, we can integrate the Markov transition probability matrix. This table 1 shows the parameter used for a single prosumer case study. A time of use tariff under TOU tariff, an average daily electricity demand of 12 kilowatt hour consumer with these 2.5 kilowatt solar PV capacity is selected, and this prosumer is simulated under this segmented Markov chain.
This is a
Therefore,
gentle 1 minute reminder.
yes, day is divided into 13 time segments. With this 13 time segment, these are the two defined derived transition probability matrices. Let's move to the result and discussion. This shows the upper figure shows the load demand of the prosumer, and the load demand is successfully met by the 4 different energy sources, as you can see in the below figure, with the constraint defined in the transition probability matrix, and with the variation of external and internal parameters of the load, with the under the varying load profiles and the varying solar PV generation scenarios. This figure shows how model effectively captures the variation and how model effectively determine the share in the prosumer load demand. So therefore, the proposed model effectively captures the load variation and adjusts the energy sharing amount based on the probabilities defined in the transition probability matrix. And also in this figure, it shows the under the varying market prices how this model behaves, and it shows the with varying market prices the model adaptively effectively determines the amount of energy shared by each energy sources while adhering to specific cost constraint. As the discussion, prosumer behavior in an energy market is closely linked with the decision based on the unit cost of energy. Therefore, the model is also the model used to verify that effectiveness of load sharing in using Markov probability matrices. So that in a conclusion, we can say that by optimizing the utilization of available energy sources, the model yields the maximum cost benefit for the prosumer, where energy mode transition happen based on the least cost. So future research can be focused on to find out the robust market design addressing fairness, cost and energy availability, and also explore the advanced modeling technique, and also investigate the blockchain and smart grid concept to the market mechanism. And also there could be pilot projects to validate this scalability in the Sri Lankan context. These are the key references that we used for our research. And thank you.
Thank you,
Thank
Shashidhara.
you. Yes.
Are there any questions?
Yes, in your model, in the state diagram, you have in slide number 15 state diagram, whether it is a Mealy machine or Moore machine.
Sorry.
Mealy and Moore machine state diagram you have shown, which depends only on the present input, not on the previous. State diagram in slide number 15. Slide number 15.
Yes, madam. In this diagram.
Previous 14. This diagram, whether
this diagram, yes.
14. Slide 14. Here.
Yes.
This diagram, it is not depending on previous input, only on present input. In that case, whether it is Mealy machine or Moore machine.
That means this represents the specific. That means this represent the Markov chain. Only a example of the Markov chain. At the moment, we simulate only a single prosumer, but this can be extended to multiple prosumers in the future work.
Okay, in the next slide, 15.
Yes, madam.
Here you left side solar battery market grid, right
yes.
side also solar battery market grid, and
yes. That madam, actually it a representative of matrix. That means the solar to solar. That means P11. That means transition probability from solar mode to solar mode. That could be in the horizontal direction as well. That is the probability of remaining in the solar mode, where the customer get the energy from the solar, but the probability of remaining in the solar mode is given by P11. Then in the next row, the battery to the solar mean that is P21. That means when the customer getting the energy from the battery, the probability of changing his energy mode to battery from the solar PV is represented by P21.
Okay. Nice presentation. Good work. Thank you. No more questions.
Okay, madam. Thank you. Thank you all.
Thank you, ma'am. Thank you, Shashikala. Moving next, I would like to invite Nivedita Cherukattu Mana to kindly present her paper titled Technological Interventions in Unpaid Care Work and Gender Dynamics. Do we have you
Hello,
here with
madam.
us?
Hello. Yes.
Ma'am, yes, I joined, madam.
Who is this?
Dr. Pankaj Chandra.
Yes, sir. Yes, sir.
Sorry for inconvenience from my side because of some technical issue. Not able to join on time.
No worries, sir. No worries.
Okay.
So we were just moving forward, sir, with the next presenter, who is Nivedita. She'll be
Yes,
presenting.
I'm here. Am I audible?
Yes, you're audible. Can you please share your screen?
Yeah, sure. Is my screen visible?
Yes, your screen is visible. Can you please put it in presenter mode?
Yeah.
Yes,
Good morning,
you may
everyone.
start.
Okay. Good afternoon, everyone. My name is Nivedita, and I'm delighted to be here today at the conference to present my research titled Technological Interventions in Unpaid Care Work and Gender Dynamics. This paper was guided and co-authored by Dr. Ansa Matthew, Dr. Ria Baby, and Dr. Jeris John. This paper is looking upon an often neglected subject, which is unpaid care work, especially the gender disparities associated with it. And our study is going to explore how technological advancements might ease this burden and promote a more equitable distribution of responsibilities between both the genders. So this is the table of contents that I'm going to present. We'll start with the keywords, go on to the introduction, research objectives, literature review, conceptual framework, methodology, key findings, implications, policy recommendations, and finally the conclusion. So before we delve into the core of the research, let me walk you through some of the keywords which is central to the study. Firstly, unpaid care work, it refers to non-remunerated activities like cooking, cleaning, and caregiving. Gender inequality majorly points to the disproportionate share of work which is mostly carried by women. And technology in this context includes tools like telehealth services and smart home devices that could potentially assist in care work. So these terms set the tone for our research inquiry. Starting with my introduction. So, unpaid care work is indispensable to both families as well as economies, yet, it remains invisible in formal labor statistics and is often undervalued in policy frameworks as well. Globally, when we look around us, women shoulder a significantly higher burden of this work, affecting their participation in the labor market and reinforcing traditional gender roles. So, the aim of this study is to explore whether and how technology can be used as a transformative tool to redistribute unpaid care work and potentially shift societal norms around gender roles. Going ahead with my research objectives, this research seeks to primarily fulfill three objectives. Firstly, to investigate how technological tools, ranging from smart devices to digital platforms, can help reduce the workload associated with unpaid care. Secondly, to analyze how these tools might influence or alter the traditional gender based division of these responsibilities. And finally, to examine policy measures that can support the integration of such technologies into everyday life and further ensure their benefits are equitably distributed. My literature review is basically divided into three sections, which is technological interventions, unpaid care work, and gender dynamics, which forms the basis of the title of my research paper. Uh, Previous studies of research papers from the years of 2003 to 2022 highlight how unpaid care work disproportionately affect women, limiting their economic participation. And research also shows that automation, AI, and digital platforms have started to influence domestic labor division. However, there are gaps which still remain in understanding how technology can equitably reshape gendered responsibilities in care work. So these are the three basic questions that I've tried to answer based on the past research papers. First question is that what is the distinguished gender dimension of poverty and what are the role of its related concepts? Secondly, what socio-demographic factors play an independent role in predicting women's attainment of higher dietary diversity, particularly among women of reproductive age who are at a risk of micronutrient deficiencies? And lastly, what are the underlying causes and implications of the significant gender disparity in unpaid care work across different sections of societies, and how does this cause unequal distribution? So basically, since the mid 1990s, there has been a debate which has emerged about the feminization of poverty, suggesting that more women are becoming poor. Telecare seeks to intervene in a landscape that is already fraught with trouble and complexity. So basically, my literature review aims to state that previous literature has thoroughly documented how unpaid care work contributes to gender inequality. And further studies show that women's participation in paid employment is frequently compromised due to these domestic obligations that they face in everyday life. Technological solutions such as automation and digital caregiving platforms have been shown to ease the household tasks, but their effectiveness in shifting social norms is still being debated. The review also touched upon the feminization of poverty and how various socio-demographic factors like age, education, and health interact with unpaid care burdens. So, these gaps in literature motivated us to investigate not just the functionality but the social implications of technology in care work. The conceptual framework draws from two theoretical approaches. The first is feminist economics, and the second is capability approach. So, the feminist economics basically critiques how traditional economies undervalues care work and highlights the structural inequalities faced by women. And the capability approach emphasizes improving people's real freedoms to pursue the lives that they value. So, basically, focusing on how technology enhances individuals' ability to participate in economic and social life. And finally, we are identifying three main variables in here, which is technological interventions, gender roles, and policy support. And these interact to shape how care work is distributed and experienced. Going ahead with our methodology, we have used a mixed method research design, which by incorporating both qualitative as well as quantitative techniques. So, qualitative data were collected through interviews with caregivers, policymakers, and tech developers. And quantitative insights were drawn from surveys and global databases such as the World Bank and OECD. We also conducted case studies in different global contexts, like for different countries as well. For example, for Japan, we conducted a study on remote monitoring for elder care. In rural India, there was telehealth reducing healthcare burdens. In South Korea, we have robotics aiding elder care. In sub-Saharan Africa, we have e-learning platforms supporting girls' education. And in Europe, we have wearable health tech improving monitoring. For the key findings, our analysis have basically revealed that technology and especially AI and automation has a tangible impact on reducing the time spent on domestic tasks. Digital platforms also allow caregivers to offer support remotely, contributing to a more flexible work-life balance. However, there is this disregard in the case of women. That is, while women are benefiting from these reductions, men's involvement in the unpaid care work remains relatively stagnant. So, this basically suggests that while technology can ease the burden, it cannot by itself resolve deeply entrenched gender roles as well. The implications of my research paper would be very significant. Firstly, technology has the potential to redefine what caregiving looks like and who is expected to do it. Reducing the burden of unpaid work could improve women's economic participation and lead to more inclusive workplaces. However, challenges still remain that many technological solutions are not affordable or accessible to marginalized communities, and cultural attitudes often resist changes in caregiving roles, especially in patriarchal societies. So, these barriers need to be addressed holistically. Now, some of the policy recommendations that I've come up with are as follows. Government should offer subsidies and incentives for care related technologies. The private sector must be encouraged to innovate with inclusivity in mind. And last but not the least, digital inclusion initiatives should aim to make technology accessible in rural as well as underserved areas, especially because we are talking in the case of a country like India, which is a developing nation. To conclude my work, I would like to say that technological interventions do hold great promise for alleviating the burden of unpaid care work and potentially transforming the gender norms. However, their success depends on thoughtful implementation supported by inclusive policy, as well as a willingness to challenge these traditional roles. And future research should explore the long term societal effects of these interventions and how to make them more accessible across different demographics. And these are the key references that supported our research, and they cover a wide range of literature from feminist economics to policy reports and international case studies. And I'm happy to share any of these sources if anyone is interested. Thank you.
Thank you so much, Nivedita, for such a wonderful presentation. Do we have any questions?
Yes, what is the percentage improvement? Your target is to enrich the women related things. How much percentage there is improvement through this work?
Person, uh, we are only aiming for a particular percentage. Like I said, there is still research going on, and we have come to a conclusion that women are the ones who are facing more difficulty in these technologies as well. So the percentage increase, I'm not definite about right now, but we are aiming for more than a 5% increase in the total advancement in terms of women.
Okay, technologies are not affordable, as you stated. Um, what do you mean by that? What technologies are available as of now?
Okay, so technologies, like I said, there are the healthcare monitors or the wearable watches, etc., which provide you healthcare benefits. But these things are not affordable by everyone in our society. Like, for example, if we speak about a country like India or like rural India, these features cannot be provided to everyone in our context.
So your technologies are related to individual women health and women time management, but
Yes.
not related to the work they are taking up, isn't it?
Yes. No, they are not.
Okay, thank you. Good presentation.
Thank you.
Thank you so much. Are
Nive-
there any more questions?
yes, ma'am. Nivedita, madam.
Yes, sir.
Hello. Yeah, nice presentation. I have only one question. How you
Yes.
are going to use AI? How you are going to use AI in your work?
Nivedita. So I think there's
Yeah, no issue, ma'am, no issue.
all right. We'll be moving forward. I would now like to request Lubna Gulnar to kindly present her paper titled MediCheck Express, a smart self-service kiosk for vital monitoring. Do we have you here with us, ma'am?
Yes, I'm here.
All right, just a second. Can you please share your screen?
Yes. Is it visible?
Yes, it's visible. You may start.
Okay, thank you. Hello, everyone. My name is Lubna Gullar. I'm a robotics engineer student, and today I'll be presenting my paper titled MediCheck Express, a smart service vital checkup system. The focus of this project is to design a system in hospitals or clinics by providing patients the ability to check their own vital signs. It aims to develop a compact and smart self-service system that will measure a variety of vital signs such as temperature, weight, height, and heart rate. Additionally, the system will use facial recognition technology, provide audio guidance, and have a tablet with multilingual health questionnaires to help users easily provide their medical history, past health problems, and allergies. This will ensure that the process is accessible for users, making hospitals' checkings more efficient. To achieve the aim of the project, several objectives were outlined, such as using sensors like ultrasonic sensor to measure height, load cells for weight measurement, finger pulse sensor to measure patient's heart rate, temperature sensor to measure body temperature, and all these results will be displayed on a LCD screen. We will be implementing a facial recognition system for patient verification using Python and OpenCV library. A speaker module will provide step-by-step audio guidance for users, and it would also include a touchscreen that allows patients to fill questionnaires. The data collected will be stored using Microsoft Excel for use of access and analysis. Self-serving kiosks are a good alternative to be used with various studies supporting this approach. Some of the key takeaways from the literature review are that self-service kiosks have shown high patient and doctor satisfaction, especially during COVID-19, where wearable devices were seen an increase in use for tracking vitals remotely. Right now, traditionally, in-person check-ins often result in incomplete information due to time constraints or patient discomfort. And finally, digital questionnaires prove to be a quick and user-friendly alternative for pre-consultation steps. There are several studies and research papers that talk about existing solutions that focus on self-monitoring and vital sign measurements. The four main systems right now are LVScan, OxyHealth, CheckMe, and mobile robots. These all have their own strengths and limitations, whether in terms of automation accuracy, user-friendliness, or implementation. These studies highlight that the balance needed between automation and human assistance, which help in making design choices for MediCheck Express. The first system, LVScan, allows patients to measure vital signs on their own and automatically store their data in electronic health records. CheckMe is a smart all-in-one device that provides accurate vital measurements with minimal time required, and it's been shown to provide promising results that correlate well with nurse-collected data. OxyHealth uses camera data to monitor vital signs like heart rate and respiration in a less invasive manner, making it ideal for settings like hospitals and psychiatric wards. Lastly, mobile robots were tested for collecting vital signs and monitoring patients undergoing radionuclide therapy, showing promising results for effectiveness and safety. To understand real-world needs, we conducted a survey involving healthcare staff and patients. Some of the results from there are that most nurses reported spending at least 5 to 10 minutes per patient just for vital checks, with added challenges like incooperative patients or manual entry. Meanwhile, patients faced an average waiting time of 30 minutes before even seeing a doctor. Overall, 70% agreed that a self-service kiosk would help, although 60% of the 70% prefer to have an human assistance. This supports our belief that automation should simplify, not replace nursing care. From these surveys and studies, several key themes emerge. The common goal across all solutions is reducing healthcare professional workload by integrating technology. However, debates still arise around the reliability of self-measurements and concerns that fully automated systems could lead to data inaccuracies. Despite these advancements, we still see gaps in the technology, and very few hospitals have fully implemented these systems on a long-term basis. MediCheck Express offers several advantages over existing solutions, mainly that it saves time for healthcare workers, reduce their workload while minimizing the chance of error by maintaining some level of manual input from patients. Additionally, unlike fully automated system, it does not replace nurses but assist them. The methodology is divided. The project was done in 6 phases. The first is system design and planning, where we defined our objectives and reviewed the literature. Sensor integration is the next step, where we use sensor and coded them using Arduino. And then we developed a software for facial recognition and language translation. And then the data was collected and stored for analysis using Excel. The system was then tested and any errors were rectified. This is the CAD design of the system that shows the system components and determine how they would fit together. A system flowchart was created to ensure that there's a proper flow. So basically the user will come in front of the KISOC and get and we facial recognize the patient, and then they can choose their language. After choosing the language, they'll have audio prompts that will help them in identifying what the task they are supposed to do. And then they can check their weight, for example, and the results will be displayed on the LCD that they can input it on the questionnaire. The softwares that we are using are Arduino, Raspberry Pi, OpenCV, and Python. These are some of the results. So you can see that this is the facial recognition results, that it identifies the patient, displays their name and mobile number, and allows patients to choose if they are verified correctly. These are the sensor reading results that show good accuracy and reliability. This is the patient questionnaires that they can access in different languages as per their need. And this is the data that's stored in the Excel, and it generates comments automatically that can be used by doctors to form diagnosis for the patients. Example, it can take the weight and it automatically calculates the BMI, suggesting if they're overweight or underweight or normal. Yeah, and then it takes the temperature to predict if they have fever or not. Similarly with the heart rate, it can catch any trends if it's abnormally high or low. To conclude, MediCheck Express is a step towards smarter, more efficient hospitals where routine tasks are automated and human patient care is preserved. Thank you, and I'm happy to take any questions.
Thank you so much, Libna. Are there any questions?
Yes, ma'am.
Yes, sir.
Nice presentation. Actually, in literature survey, you have mentioned 4 or 5 applications, or you can say tools. But in terms of accuracy, which one is best? Either existing or yours?
In terms of accuracy, I would say the existing solution is more correct, just because they use more advanced sensors. But
Okay.
as for now, my product is just a small minimal prototype. But if you replace the sensors to the one that's at industrial level, it will show promising results too.
Okay. And last question from my side. Just tell me approximate cost of your project.
So we have not calculated the cost, so I will be unable to provide that answer.
Okay. Because of what you are using some sensors, right? Now you are using devices.
Yeah, but these are the cheap, the sensors that are like smaller. So we will need to, if you are using this in real life, we would use like a industrial size sensor. So yeah, we don't know the price estimate.
Okay, no issue. Good project. Thank you.
Thank you. Thank you so much.
Thank you, sir. Any more questions? Right. Since there are no more questions, we'll be moving forward. Thank you so much, Lubna.
Thank you.
Moving forward, I would like to request Jovi Ruth.
Yes, ma'am, I'm here.
Yes. Kindly present your paper titled Pinoy Tasker, Cleaning Service Marketplace Mobile Application.
Okay, can I share now the screen?
Yes, you can share. Also, there is background disturbance at your end. Kindly take care of it. Yes, your screen is visible. You may start.
Good afternoon, everyone. My name is Stuart Mobielska, and joining me today is my co-author, Luis Pachang. We are from the University of Concepcion in the Philippines. It is our pleasure to present Pinoy Tasker, mobile application designed to revolutionize the cleaning service industry in the country. This digital solution aims to streamline service accessibility, enhance efficiency, and provide a seamless experience for both service providers and clients. To guide you through our discussion today, here's the roadmap for this presentation. First, introduction, followed by the statement of the problem, objectives, methodology, system architecture, results, conclusion, recommendation, and conclusion. Introduction. The world is experiencing rapid digital transformation with business and consumer increasingly relying on online platforms for convenience and efficiency. The COVID-19 pandemic further accelerated this trend, emphasizing the need for contactless services and reliable digital marketplaces. The Philippines has embraced digital shift of over 73% internet penetration and a growing dependence on mobile applications and essential services. We have seen e-commerce giants like Lazada and Shopee dominate the retail sector, while transportation personal service have flourished through Grab and Fast. However, one industry remains underserved, which is the cleaning service sector. Despite the increasing demand for professional, reliable, and eco-friendly cleaning services, existing platforms fail to provide accessibility, flexibility, and inclusivity. Many rely on rigid operational models that limit the participation of independent cleaners. The household cleaners market is projected to reach about 713.89 million by 2025 with a steady annual growth rate of 4.11%. This represents a significant opportunity for innovation in the cleaning service marketplace in the Philippines. To address this challenge, Pinoy Cluster was developed as a cross-platform mobile application that is available for iOS and Android, designed to bridge the gap between the independent providers and clients, enhance trust, efficiency, convenience, and in-service transaction, utilize scalable and secure technology infrastructure. Pinoy Tasker leverages the power of digital transformation to create an inclusive, efficient, and scalable solution for the growing cleaning service industry in the Philippines. Through this platform, it will empower independent service providers, improve market accessibility, and redefine how cleaning service are booked and delivered. Statement of the problem. First, lack of structure and reliable booking system. Finding a cleaner is often undone through manual referrals or social media posts, making the process unreliable. Second, limited access to verified and professional cleaners. Customers also struggle to find skilled and trustworthy cleaners. Since there is no centralized platform to vet service providers, the quality and reliability become a major concern. Inconsistent pricing and payment security. Another problem is the lack of standardized problems and cash-based transactions dominate the industry, leading to risk of fraud, non-payment, and lack of financial security. Lack of user feedback and rating system. Most platforms lack transparent review system, making it hard for customers to assess service quality before hiring a cleaner. At the same time, cleaners struggle to build their credibility, limiting their ability to gain more clients. Lastly, limited opportunities for independent cleaners. Many existing platforms prioritize business partnerships, leaving freelance cleaners with fewer opportunities. Independent service providers face barriers in trying to enter the cleaning service industry. Objectives. This research aimed to design and develop Pinoy Tasker cleaning service market-based mobile application that simplifies and enhances the process of connecting cleaning service providers with the clients. It aims to develop Pinoy Tasker to enhance the cleaning service marketplace by providing a secure and user-friendly registration process for both clients and service providers, an efficient task management system that allows users to outline, manage, and match tasks based on preferences, a secure payment system to facilitate seamless financial transaction, real-time communication between clients and service providers to enhance interaction and coordination, and transparent feedback system to foster trust, continuous improvement, and informed decision making. Evaluate the user experience of both Tasker and Poster while using the Pinoy Tasker application. Methodology. To ensure the structured and efficient development of Pinoy Tasker, we utilize the solo agile waterfall hybrid development methodology, a tailored approach designed for Pinoy Taskers. This methodology combines the structured sequential nature of the waterfall model with the flexibility of agile, ensuring a balance between planning and adaptability. The development process follows these key phases: requirement analysis, planning, implementation, integration and testing, deployment and maintenance. By integrating agile adaptability with the waterfall model structured phases, Pinoy Tasker ensure an efficient, secure, and scalable development process that meets user expectation. System architecture. The diagram illustrates the system architecture of the Pinoy Tasker mobile application. At the center of architecture is the database that which store all information such as user profile, task details, payments, transaction history, and feedback. The API layer acts as the bridge between the database and the user. It handles all the data processing, business logic, and communication between the system and the front-end application, which is the web app and mobile application. The system supports 3 user roles, which is the marketplace admin, tasker, and post. All components and interfaces are connected via the internet, indicating an architecture that ensures real-time data sensing and updates. The arrows in the diagram represent the flow of data, highlighting bidirectional communication between the interfaces and the central components. This architecture ensures seamless interaction and efficient operation of the Pinoy Tasker platform. The results. The user experience evaluation for Pinoy Tasker gathered responses from 30 service providers with more than taskers, assessing various aspects of the application functionality, security, and efficiency. The overall user experience received a strong 82.62% satisfaction rate, indicating a positive reception among service providers using the platform. Summary of poster user experience evaluation. A quantitative survey of 30 poster or clients was conducted to evaluate their experience using Pinoy Tasker. The survey focused on application functionality, security, and efficiency, yielding a strong 83.76% satisfaction rate, which reflect a highly favorable response from the clients using the app to find cleaning service providers. The user experience evaluation of the Pinoy Tasker, both Tasker and Poster, presents a positive outlook on the platform performance with satisfaction rates of 82.62% and 83.76%, respectively. The result reflects strong user approval across the service providers and clients. Tasker found an app effective for securing job managing services, while Poster appreciated the platform ease of use and reliability in connecting with cleaning services. Despite the high satisfaction levels, both groups highlighted the need for improvement in task management, payment-related features. Addressing these areas will further elevate the overall user experience, strengthen the trust in the platform, and introduce a dispute resolution feature for the recommendation. Enable Tasker and Poster to mutually resolve or revise tasks to foster trust and reduce conflicts. Enhance onboard and customer support, simplify the registration process, offer accessible reporting, user engagement, and satisfaction. Add more payment gateways. Integrate multiple secure payment options to improve transaction, flexibility, and user convenience. These are the example of mobile applications. This is the registration screen, task management screen, payment screen. And this research was built on the work of industry experts and reliable sources. Complete references are listed here for your review. Thank you for your time and attention. Thank you for allowing me to present my study today. Thank you so much, ma'am. Hello. Hello. Hello.
Yes. Hello.
Yes.
Yes, ma'am. I'm done now, ma'am.
Yes, I'm sorry, there was some technical error at my end, hence I was not able to speak. Thank you so much for your presentation. Are there any
Thank you,
questions?
ma'am.
Do you have any hardware components in the implementation? Which tool you have used?
The tool that I use for the development of my mobile app, ma'am, is I use it for my program language. For my API is PHP, and for my front end for the web application, I use JavaScript, and for the design, HTML and CSS, and for my mobile app, ma'am, I use Flutter, and the API and my API and the database are hosted on my own server, ma'am. So it is run under webmin under Unix.
Okay, nice work, presentation. Thank you.
Thank you so much, ma'am.
Thank you, ma'am. Are there any other questions? Sir?
Hello.
Yes, sir.
Yeah, nice
Hello, sir.
presentation.
Thank you
Yeah,
so much,
just
sir.
tell me. Yeah, just tell me your stakeholders.
My stakeholders, sir, is like in the Philippines. So the allowed age to work is 18 years old and above. So all 18 years old and above are able to be a tasker or a
Okay,
poster.
so yeah, you are going to consider for your country only.
Yeah, yes, sir.
Yeah, yeah, good work, good work. Yeah, thank you.
Thank you so much, sir.
Thank you
Yeah,
so
and
much.
please try. Yes, please try to extend for other countries.
Thank you, sir.
Yeah.
Thank you so much. Thank
Thank
you so
you
much for
so
your
much, ma'am.
presentation. Thank you, sir.
Thank you so much, ma'am.
Moving forward, I would like to invite Arijit Saha to kindly present his paper titled Real-Time Water Refill Monitoring and Management System via Wireless Network using UDP Protocol. Do we have you here with us, Arijit?
Yes, ma'am. Am I audible clearly?
Yes, you're audible, sir.
Uh, Should I share my screen?
Yes, please.
Is it in presentation mode?
Yes, your screen is visible. You may start.
Uh, Hello, everyone. Good afternoon. Myself, Arjit Shah. I am the corresponding author of the paper entitled Real-Time Water Refill Monitoring and Management System via Wireless Network using UDP protocol. Here are the content I will cover in this presentation session. Introduction. As from the title, some questions might arise on your mind, like what is the water refill monitoring and management system, and why it is necessary to include the wireless network. This system is a sophisticated system designed to help water refilling stations efficiently manage their operations, track inventory, monitor water level, and optimize the processes, often using technology to automate tasks and improve efficiency. And incorporation of the wireless network means uses the sensor to monitor water levels in tanks or reservoirs, transmitting data wirelessly to a central system for management and alerts, often employing protocols like UDP, ZigBee, or LoRa for efficient data transfer. And what is the purpose of this research? You know that water is an essential thing in the human being, and in the world, many countries, rural regions, and areas are experiencing water shortages. Furthermore, Bangladesh is an agricultural country. Water is essential in irrigation too. So, it is important to utilize the water properly and manage this system efficiently. And the goal of this research is to develop a cost-effective, real-time, automatic, wireless refill monitoring and management system using wireless network with the help of ESP32 and ESP8266 microcontrollers that optimize the system through synchronous client-server display, utilizing the UDP or user diagram protocol for efficient data transmission and communication. And further, we validate the system accuracy, reliability, and scalability for widespread adoption in automated water management application. and ensure the water level flow monitoring with high precision, enhanced accuracy, user-friendly interfaces at low cost of $13.2. And next, I will talk about the system design. This figure 1 illustrates the functionality of the proposed system, which is structured into two main components, client system and the server system. The client system controlled by the ES32 and interactions among with the key components like the water flow sensor, pump motor, motor driver, keypad, sonar sensor, and OLED display. And the motor driver regulates the pump motor to dispense water, while the flow sensor measures the volume functions indicating the flight variation. The sonar sensor continues to monitor the water level, ensure the precise reflecting, and users can input desired quantities via the system keypad. And the system display connected via ITC communication. And figure 1b here, it is the server system which acts as both as a receiver and the data processing unit. The ESP8266 microcontroller manages data reception and processing, establishing a connection with the ESP8266 client, and using the UDP protocol, the ESP32 transmits sensor data as UDP packets over a wireless network, and which the ESP8266 reconstruct and process. This is the system flowchart. Here, figure 2a outlines the operational sequence of the proposed system. It begins with the system initialization, activating components and setting variables. The system and then waits for the user input with the keypad. In the keypad, the A button reset the settings, while number 0 to 9 sets the target volume water. And if the target volume initialized greater than 0, the motor starts pumping, and pressing D activates the dispensing. And after the integration initialization, and the system continuously updates the dispense volume, calculates bill, and monitors the water level. That will shown in the result analysis part. Just for the summary here. And figure 2b here illustrates the client system operations, beginning with the Wi-Fi connection setup for communication with the server. Initially, the UDP ports also you can configure the IP address to enable the data transmission. And the client system then sends UDP packets containing initial data such as target volume, dispense, etc. Passwords for reliable operation. And figure 2c depicts the server system operation, which starts by setting up the Wi-Fi access point and configuring the static local IP settings. It continuously waits for the incoming UDP packets from the client, extracts data on water dispensing parameters. Additionally, all the data can be saved in the Excel and Arduino sheet for further analysis and record keeping. And this is the hardware and implementation part. Figure 3 displays the interconnection of all components in the client and server system, including all the sensors and controllers. In this prototype, for efficient water flow is maintained through the 3 mm thick and 40 cm long pipe and 1.5 liter capacity water tank has been used. And just the result analysis part. This system testing process involved measuring 30, 60, 100, 130, 100 systems, 200 ml of water 20 times each, as shown in the figure 4a. And the graph represents the individual measurement attempts with functionality indicating slight variations. The average values are calculated to assess system accuracy. Here, figure 4b illustrates the experimental comparison of water level data transmission between the client and the server. The result shows that the client successfully transmits water level percentage with the server receiving nearly identical values. For example, 100% of water transmission match perfectly, while 95.56 results in 96%, and the lower transmission of 10.65 corresponds to 11% received. The serial monitor in figure 5b represents the communication link between the client and the subsystem. In the configuration 1, UDP port 1 is designated for transmitting and receiving the target value. UDP port 2 handles the dispensing value. UDP port 3 is responsible for the bill amount, and UDP port 4 is used for the transmitting and receiving water level. Here, figure 5a, the message indicates that four client ports are connected to the UDP server on the device. Conversely, figure 5b represents the utilizing the UDP for 4 distinct ports, provides a reliable, efficient method for data delivery. These connections allow the data exchange within a range of 16 to 22 meters and it's typically established in approximately 2 seconds. The process of the data packets transmitting from the client part illustrated in the figure 6a. Each individual packet is transmitted in distinct port, thereby enabling the streamlined and efficient transfer of data between the client and the server. And figure 6b depicts the series of data packets received during the interval from 0.521 to 0.66. The client data and packets for the three target dispensing for 30, 60, and 100 ml are discussed in the figure 7. The system calculates the dispensing value and bill amount based on the target value set. When the target value is 30 ml, the dispensing value is 0.63 ml and the bill amount is 0.63 taka. And the simultaneously, the system measures the water level of measurable tank, which is found is 98.78% depicted in figure 7a. And the similar calculations are occurred for the target value of 60 and 100 ml also in the figure 7b and 7c. And figure 8 here demonstrates server's data and packet processing capabilities in two formats. Here Arduino spreadsheet in figure 8a and 8b for the Excel sheet. Arduino spreadsheet is employed to monitor the packets received from the client, extracting 4 packets that displays key values, including the target value, dispensing value, and bill amount, specifically for 60 ml. Additionally, the extracted data is saved in the Excel sheet as shown in the figure 8b, which includes the records for both 30 ml and 60 ml. And figure 9F and 9B displays the result of the water refilling process as shown in the client system and the server system with the help of LED screen. Each screen provides essential information, including a target value of 30 ml and actual dispense value of volume of 31.26 ml and the bill amount of 0.62 and the current water level of 97.56 in the measurable tank, and both displays the confirm that the server has successfully received the process data and the data from the client, ensuring that both systems are synchronized and provide consistent information. And here are the
This
equations
is a
that are
gentle
used to
1 minute reminder.
here is the calculation for the calculated dose V. And table 1 represents the accuracy of the focus system for various water volumes and comparing the mean measured value of the expected volume. This finding demonstrates that a high level of accuracy across all measurements, with the lowest accuracy observed in the 160 ml case, indicate the system performed reliable in measuring water volumes. And future research study is to enhance the systems by integrating the machine learning for predictive analytics and resource optimization. And it also focuses on the expanding the combination range using protocols like LoRa or ZigBee for remote application and improving sustainability for larger scale implementation. And furthermore, test the system scalability and long-term dependability by developing it in the real-life scenario. And conclusion, the research demonstrates the prototype of an efficient real-time water refill monitoring and management system using the ESP32 and ESP8266 controller. And the proposed system costs around 13.2 per unit. Its cost effectiveness and scalability make widespread adoption feasibility. And data transmission between the ESP32 two microcontrollers via UDP confirm the water level transmission accuracy within a dependable communication range of 60 to 22 meters. And finally, it can be said that the implemented technology can be used in the smart irrigation systems to optimize the consumption of water and power resources, particularly in the cities or rural areas where experiencing the water shortages to elevate the strain on farmers. And here are the references and that we used to conduct our research. And thank you. If you have any question, please.
Thank you so much, Arijit. Are there any questions?
Hello, sir.
Yes, sir.
Nice topic, nice presentation.
Thank you, sir.
But yes, I have only one doubt.
Yes, sir.
Yes, why WSN only? And why UDP only?
Sir, we use the wireless sensor network because normally, if we consider Bangladesh scenario, Wasa
Okay.
is the water supplier, and the
Okay.
receiver is a building. So we need to communicate the two systems, server and receiver, with the wireless network.
Okay.
Without if we use the wired connection, it can be destroyed anytime. So you use the wireless network. Second one is the sir.
Okay. So,
Yes, sir.
have you studied same scenario for another country?
Sir, it can be deployable in any country. It's a prototype. It can be developed deployed in industrial also.
Okay, good work. Thank you.
Okay, thank you, sir.
Thank you, sir. Thank you, Arijit. Yes, ma'am.
How, what is the maximum number of clients you are connecting? Maximum number of clients.
Ma'am, we are make the prototype. So it can be we just do for six members. That six email, six different email we are contact 30, 60, 100, 160, 120. So it can be increased if you want.
Okay. Oh, why only one server? You are telling client is the sending point and server is the receiving point.
Yes. Because ma'am,
Sending are
ma'am,
many.
ma'am, because tank is in the receiving point. Water tanks are established in the receiver. Means building is the transmitting point. They measure the how much water is they are consuming from the water. For example, I consider for Bangladesh. Water is
Okay. What is the distance? What is the distance between them?
we for this instance we use the 16 to 22 meter. 16 to 22 meter transmitting. Server
Okay.
and
Is there
receiver.
possibility to increase it? It is very less, I think, isn't it?
That's why, ma'am, we are thinking to other two protocols like LoRa and BGP. Right now, we
Okay.
work only UDP.
Yes, yes, yes. You
Further,
told.
we'll work on this one.
Okay. Thank you. No more questions. Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, Arijit. Moving forward, I request Shubhranshu Shekhar to kindly present his paper titled Robotic Plant Health Monitoring and Disease Control System for Sustainable Farming. Do we have you here with us, Shubhranshu?
Yes, I'm just here.
All right, just a second. Yes, please share your screen.
Yeah, sure.
Yes, your screen is visible. You may start.
Yeah. So basically, good afternoon, everyone. Myself, Subhranshu Sekhar, and I'm from SRM Institute of Science and Technology, Cotton Kolata. So I'm going to do the paper presentation for my on behalf of my teammates. So basically, we were doing a bit of research. We were doing a bit of research on what should we work on, and the first thing that came to our mind was agriculture because it's directly or indirectly affecting our life every day. And we were going through a bit of research, and we found out that approximately 40% of the global food crops are actually getting affected every year because they are not being predicted early. So that's how we came up with the problem statement. It was like we tried to build a robotic plant health monitoring and disease control system, specifically focused on the sustainable farming. So it was like the main aim for us was like to detect the plant disease quite early and automate the whole system so that there is no manual required. The same way we went through the literature survey, and there were few literature surveys that's there over here, and most of them were basically focused on the deep learning, where they will either classify the image based on the patches that's there. They will classify whether it's healthy or it's not. So that was most of the highlights that we saw through all the literature's review. Few of them were also using detection as well as the classification. For more like out of all the reviews that we saw, we went to a point where we understood that there are few major problems that's there. There's basically major difference between the tech and the agriculture thing that was there, and it was mainly the manual labor. So basically, manual labor while we go to a large farm, it's either very complex or it's also very it's not cost effective, as you need a lot of manual physical labors there, right? So it's also complex as well as the cost will be higher. So the same way, our objective was to solve this problem and detect the plant disease as early as we could. Also automate the whole system, and we did it by we did it with a few technologies. Especially, we implemented the line following navigation for efficient coverage of the whole farm. So basically, this is based on a farm that's being pre-planned. Like it's a structured farming. It's based on a structured farming. So there were few existing solutions that we went through, and we found that there was basically mainly a manual inspection method where people just go physically and see the plant with the naked eye, and they predict whether the plant is healthy or not. And also we saw that there were few mobile apps that were available. Basically, it's just an app where you can click the picture and it'll detect whether the plant is healthy or not. And there were few of the advanced things that we actually saw was stationary IoT sensors. Basically, we saw a camera that was a CCTV camera that had high definition. The pixels were high definition, so it could actually capture images from quite a far, and then it can detect whether the plant is healthy or not. So based on all the existing solutions that were already there, we saw a huge problem that there was nothing like a robot that could move around the farm and can navigate whether the plant is healthy or not, and can give you the solution as well. So for that, we came up with a methodology that we need to build something that have the whole automated solution. And for that, we have used, so this is the hardware block diagram that's there for our project. So the camera module, which is already being mounted, that already comes with that's an inbuilt camera module that comes with the AMB82 mini microcontroller. So this camera module basically captures the images on both the sides of the line following. So it'll capture the images of both the sides. And after that, after the image has been captured, it is being sent to the microcontroller, where we have pre-trained the model in our system, which will where we have fine-tuned the model in our system, which will actually classify the image whether the image is healthy or not. And if it's healthy, the bot will be moving forward. And if it's not healthy, if it's being classified as unhealthy, then the action will be taken by Arduino Nano, where the Arduino Nano will actually take the action by spraying, which will actually trigger the pesticides sprayer, and then spray the pesticides on the plant. Also, the Arduino Uno, the function of Arduino Uno is quite basic. It's basically follows the line following sensor, where the IR sensors has been there, and after few interval of time, which is being set by us, it moves forward. So this is again the workflow of the project that we have worked on. So basically, it's like firstly the board will start moving, and when the moment it captures the images, it sends it to the microcontroller, and then microcontroller classifies it. Later it's being sent to the after the classification, either it's diseased or healthy. It is being sent to the next it is being sent to the Arduino Nano for the action if it's disease. If it's not, then again the bot moves forward. Just a sec. Yeah. So this is the hardware that we have worked on. This is what we have made. This is just a line following the sensor that's there, IR sensors, and this is the camera module and AMB mini. So that was the hardware that we have built. This is just a prototype, but it was working fine with everything. And for the software implementation, we have used a data set that was available on the Kaggle. It was like, and basically we mostly focused on the potato leaf data set, and we trained almost like 1600 images. And we divided the data set into like training, validation, and testing, of course, for everything. And we came up with a good amount of accuracy for that. And we have trained with the basic CNN model, the basic architecture of the CNN model. We did not do any changes in that because it was working perfectly for us. And this is the result and discussion where we got actually 99% of accuracy on the prediction of whether it's diseased or not. And then for the future work, we have understood that we need to do it on a large scale. So we need a lot of robots. Along with that, we need a lot of bots like this. Along with that, we also need a server that can manage all of them. So basically, it will reduce the manual, it will cut off the manual labor completely. So that's the plan. Thank you, everyone. And I'm just open to all the questions that if you have any questions.
Thank you so much, Shubhranshu, for the wonderful presentation. Do we have any questions?
Yes, the CNN, which one you have used, 1D, 2D, or 3D? CNN.
Oh yeah, so we have used basically 2D. You're asking about which architecture we have used, right?
Yes, you have converted 2D.
Yeah, we have converted 2D into 1D.
And you are using a lot of images, no? Lot of images.
Hello.
Yeah.
Hello, sir.
Sir, ma'am is asking a question. Once she's done, you may take this.
Yes.
Mhm.
Yes,
Yes.
ma'am.
Okay, what is the overall budget Overall budget?
So it was 6,000 INR. In Indian rupees, it was around 6,000.
How many robots you used?
We just made one prototype. This-
Okay.
Mhm.
Thank you. No more questions. Sir will ask.
Yes, ma'am.
Thank you, ma'am. Sir,
Yeah,
your question.
ma'am, really nice question. And Shekhar sir, you said you converted 2D to 1D.
Yes, yes, sir.
So how you converted 2D to 1D?
Yeah, it was like basically there was one more reason that we needed to reduce the size of it. So the convolution layer have a lot of layers in them. So there were
So
two.
basically you are working on image, am I right?
Yes, sir, yes, sir.
So for image your 2D works best.
Yeah, for 2D works best, but 1D have the highest speed.
So that's why you converted.
Yeah, so it's like if there is 2D array, then we convert it into 1D array.
And then for 1D data set, we have multiple models.
Yes,
Then
we
no
do.
need to use CNN.
Yes, we do, but we just stuck to the basic model. So
Oh, okay. No issue. Happy with your defense. Good work.
okay,
Thank you.
sir. Thank you, sir.
Thank you, sir. Thank you, Shubhranshu. Moving forward, I would like to invite Tarushi Singh to kindly present a paper titled Smart Irrigation System with Weather Forecast Integration. Do we have you here with us, Tarushi?
Yes. Hello? Can you hear me?
Yes, now I can hear you. I'll stop sharing so that you can share your screen. Yes, your screen is visible, so you may start.
Yes, just 1 second. Yeah. Is my screen visible?
Yes, your screen is visible. Please start.
Okay. Good afternoon, everyone. I'm honored to be here today to present our research on smart irrigation system with weather forecast integration, a project designed to tackle one of the most pressing issues of our time, water scarcity in agriculture. The authors of this paper are Arulya Ashokan, Tarushi Singh, Vishnupriya Gaur, and co-authors are Vasandeva Suryakala and Anilid Bala. We're from Department of Electronics and Communication Engineering in SRM Institute of Science and Technology in India. Water is one of the most precious yet limited resources on Earth. Agriculture alone consumes about 70% of global freshwater resources, yet inefficient irrigation leads to massive water wastage. Farmers often rely on traditional irrigation methods, which are not only labor intensive, but also unsustainable in the long run. With climate change causing unpredictable rainfall patterns and rising temperatures, we need intelligent, automated solutions to optimize water use while ensuring crop productivity. This is where technology steps in. By combining Internet of Things, MQTT communication, and RTOS, we have developed a smart irrigation system that makes real-time decisions based on sensor data and weather forecasts. Before I dive into the technical details, let's take a moment to think. How often do farmers waste water because they lack real-time information? And how can automation reduce labor and improve crop health? Our system answers these questions by reducing water wastage, automating irrigation, and providing real-time control. Let's consider an example. Imagine a farmer who irrigates his crops manually. He waters his fields every morning, unaware of the fact that it might rain later that evening. The result, wasted water, increased costs, and potential overwatering of crops. Now, picture a system that monitors soil moisture levels automatically, checks real-time weather forecasts, and decides when to irrigate based on actual crop needs. It also allows the farmer to control it remotely. That's exactly what our project does. It eliminates guesswork and ensures optimal irrigation without human intervention. This is a literature survey that helped us understand the situation of our current irrigation systems and drove us towards making a more efficient system that overcomes the problems these previous systems have faced. Our problem statement is traditional irrigation systems rely on fixed schedules or manual operation, leading to inefficient water usage or overwatering or underwatering. And farmers often lack real-time insights into soil conditions, weather forecasts, and system performance, making it difficult to optimize irrigation. Additionally, managing multiple irrigation-related tasks simultaneously, such as data and sensor acquisition, decision-making, and communication, can be challenging in embedded systems and with limited resources. Our system is designed with three primary objectives. First is automated irrigation. The system uses real-time sensor data to determine when irrigation is needed, ensuring efficient water usage. Remote monitoring and control is our second objective, where farmers can access real-time data and manually override the system if necessary using MQTT-based communication. Third, improve water efficiency, where the combination of RTOS, real-time operating system, and optimized scheduling reduces power consumption and ensures that tasks run smoothly and efficiently. Now let's talk about the technology behind our solution. Our system consists of the ESP32 microcontroller, which is chosen for its Wi-Fi capability, lower power consumption, and multitasking abilities. We used a soil moisture sensor, temperature and humidity sensor, and a pH sensor to gather real-time environmental data. We used MQTT protocol, which enables secure and real-time communication, allowing farmers to monitor irrigation remotely, and used RTOS, which is a tool that efficiently manages multiple tasks, ensuring that system runs without delays or any inefficiencies. How does this work? The sensors collect data on soil moisture, temperature, and the pH levels of the soil. The system analyzes the data and compares it with some preset thresholds. If the soil is too dry, the system automatically activates irrigation. If rainfall is predicted, irrigation is postponed to prevent overwater. Farmers receive real-time notifications and can override decisions if needed. After extensive testing, our system demonstrated remarkable improvements in three key areas. First is the water consumption reduction. Our system efficiently reduced water usage. This is because the system only irrigates when necessary, avoiding unnecessary water loss. Next, farmers could monitor and control irrigation remotely through an intuitive interface. This provided them with real-time insights and greater flexibility, even when they weren't physically present on the farm. Next, the integration of RTOS helped optimize task scheduling, ensuring that the system consumed minimal power while maintaining high efficiency. This is our dashboard designed to provide farmers with real-time insights into soil conditions, leveraging MQTT for efficient lightweight messaging and Node-RED for a structured and user-friendly interface. We developed this platform to facilitate seamless interaction with the irrigation system. The dashboard features dynamic charts displaying key environmental parameters, including temperature, humidity, and pH levels over time. Additionally, a dedicated weather section provides real-time updates on local climatic conditions. Furthermore, the integrated control switch allows user to remotely operate the irrigation pump, ensuring greater flexibility and efficiency in water management. This is our hardware prototype. The setup includes a container with two distinct soil samples, one dry and one wet, along with varying pH levels to demonstrate differences in soil acidity. Multiple sensors are integrated into the system to monitor key parameters, while an LCD display provides real-time readings of the collected data, ensuring clear and immediate insights into soil conditions. To deep dive in, we have a close-up to our dry soil as well as our wet soil. The dashboard showed the real-time soil moisture of both the soils, and we set a threshold of 20, where if it crossed it, the pump would automatically activate if it was beneath it and would stop watering if it was above it. The LCD showed the humidity, the temperature, as well as if rain is expected in the next 1 or 2 hours. The pH level sensor sends the acidity of the soils, and the dynamic chart showed the pH level of the soil over time. And the pump would automatically activate, releasing any fertilizer needed to bring down the acidity or increase it depending on the type of soil and the type of crop being grown. While our system is already highly effective, we believe there is still room for improvement. We can integrate machine learning algorithms where we can analyze historical weather patterns and optimize irrigation schedules even further. To make the system more energy efficient and eco-friendly, we plan to introduce solar-powered irrigation pumps. And by extending connectivity through LoRaWAN, we can enable smart irrigation in remote areas where internet access is limited. To summarize, our project successfully developed an IoT-based smart irrigation system that integrates ESP32 for microcontroller-based automation, MQTT for remote communication, and RTOS for real-time task scheduling. By implementing this system, we have shown that smart technology can significantly enhance agricultural efficiency, conserve precious water resources, and help farmers make better decisions. Imagine a future where every farm is equipped with intelligent, self-sustaining irrigation, one that responds in real time to climate conditions, soil health, and weather forecasts. This is not just a concept for the future. This is something we can achieve today with the right technology and innovation. These are our references. And before I conclude, I would like to open the floor for any questions or discussions you may have. Thank you.
Thank you, Tarushi. Are there any questions?
Hello.
Yes, sir.
Ma'am, nice presentation, nice topic.
Thank
So
you, sir.
have you discussed your project with any farmer?
No, sir, but one of our yes, sir.
Yes, sir. Have you discussed with any farmer?
We discussed this project with one of the author's uncles who manages he's an IFS, and discussed our project with him, asking him about how efficient this might be and what are the current situation in India specifically, and he encouraged us to continue working on it.
Okay. Okay. Project is nice, but actually in terms of Indian context, reality is missing.
Yes, sir.
Yeah. Means, as a computer engineer, we can say anything, but as a farmer, they have different problems.
Yes, sir.
Okay, good. Thank you.
Thank you.
Dashboard is designed using which tool? Dashboard?
It's Node-RED.
Repeat.
Node-RED.
Node-RED.
We use MQTT protocol for the sending. Node-RED is basically a flow-based programming tool, which is used for IoT application. It helps in live monitoring and real-time data visualization. We integrated it with our MQTT, which is a message queuing telemetry transport for fast messaging between ESP32 and the dashboard. And Node-RED processed this data and displayed the sensor data, ensuring seamless communication.
RTOS is for? RTOS you have used?
RTOS is a tool that is used for real-time operating. It's real-time operating system we use to efficient multitasking and timely execution of critical tasks. Because unlike traditional microcontroller programs, RTOS helps in task scheduling and priority management and synchronization, which is important for an IoT-based smart irrigation process.
Okay. Thank you.
Thank you.
Thank you, ma'am. Thank you, Tarushi. All right. We'll be moving forward. I would now like to call KGAP Dilshan to kindly present his paper titled Use of Artificial Intelligence in the Automobile Industry. Do we have you here with us?
Yes, I am here.
All right, just a second. I'll stop presenting. Yes, you can share your screen.
Okay. Is visible my screen?
Yes, your screen is visible.
Yeah. Good evening, all. I am KGAP Prithvidishan, and today I here to present our research paper under the topic Use of Artificial Intelligence in the Automobile Industry. This is an ongoing research. This is the overview of my presentation. Let me start the presentation by introducing AI in the automobile industry. Welcome to the future of automobile, where artificial intelligence, coined by John McCarthy in 1956, is reshaping the automobile industry. This radical transformation sees collaboration among giants like Mercedes-Benz, Waymo, Tesla, Audi, Volkswagen, and Microsoft to harness AI's potential. Together, they aim to address critical challenges like accidents, traffic congestions, safety standards, and environmental concerns. Join me as we navigate this transformative journey at the intersection of technology and transportation. Most importantly, let me tell the aim of our paper. Study and explore the deep effects of AI on the automobile sector, including its many uses, effects on efficiency and safety, and crucial role in determining the direction of automobile technology in the future. The automobile industry, dynamic and ever evolving, plays a pivotal role in global transportation. In this paper, we will explore its current state, challenges, and future directions. From traditional manufacturing to cutting-edge innovations, understanding this industry landscape is crucial to contextualize transformative impact of artificial intelligence. Let's explore the spectrum of automation levels in the vehicle, each defining a unique interaction between technology and the driver. At level 1, there is no any drive assistance. After level 2, introduces adaptive cruise control, ensuring a safer distance from the car ahead. The advanced driver assist takes control of steering, braking, and acceleration. At level 3, enables actions like parking while the human remains the primary driver. At level 4, human interaction is not required. Vehicles can be controlled by human override feature if necessary. Finally, level 5, vehicle operates without human intervention. The human becomes a passenger rather than a driver. Understanding these levels is crucial to appropriate the evolving landscape of automated driving technology. Let's go through the applications of AI in the automobile industry nowadays. With application spanning multiple areas including advanced driver assistance system, manufacturing optimization, in-cabin experience, aerodynamic optimization, energy efficiency, and predictive maintenance. Artificial intelligence is completely changing the automobile sector. Let me briefly discuss each of them. First, autonomous vehicle and advanced driver assistance system. AI powers self-driving cars and advanced driver assistance systems, enhancing safety with features like collision avoidance and adaptive cruise control. Companies like Tesla, Waymo, and Mercedes are advancing automation, enabling hands-free driving under specific conditions. Manufacturing optimization. AI improves manufacturing by automating assembly line, detecting defects in real time, and optimizing logistics. Tesla's gigafactories use AI-driven robotics, while BMW integrates AI for quality control, reducing cost and increasing production speed. In-cabin experience. AI enhances the driving experience through voice recognition, personalized infotainment, and driver monitoring system that adjust vehicle setting based on driver behavior for increased comfort and safety. Next, aerodynamic optimization. AI-driven design techniques optimize aerodynamics by reducing drag and improving vehicle performance. CNN-based model help automakers predict airflow patterns efficiently, shortening designing cycle and enhancing fuel efficiency. Then, energy efficiency. AI plays a key role of electric vehicle energy management, optimizing battery performance and sustainability. Tesla's AI-driven battery management system extends battery life, while Waymo taxis use AI for energy-efficient route planning. Predictive maintenance. AI-powered predictive maintenance helps reduce repair cost and downtime by detecting potential issues early. Tesla's over-the-air diagnostic combined with AI-driven analytical from the BMW and Audi ensure reliable vehicle performance and extended component lifespan. Now let's move to the current issues in this field. AI-powered vehicles face several challenges that impact their adoption and efficiency. Data privacy and cybersecurity. These vehicles are vulnerable to cyber threats, making AI-driven intrusion detection, blockchain security, and quantum cryptography essential for protection. Complexity of autonomous driving. Navigating unpredictable environments and real-time decision-making remain major challenges, limiting full automation. Regulatory and legal challenges. Inconsistent policies, unclear liability, and slow regulatory updates hinder widespread AI adoption. High development cost. Significant R&D investment make it difficult for smaller manufacturers to compete. Next, ethical implication and bias. AI faces dilemmas in life-threatening situations, raising concern about fairness and public trust. Infrastructure dependency. Autonomous vehicles need advanced roads and networks, limiting their use of some regions. Environmental sustainability. AI helps optimize fuel efficiency and EV battery life, reducing the industrial environmental footprint. Now, I would like to summarize my paper content. AI is playing a major role in transforming the automobile industry, making vehicles safer, smarter, and more efficient. From improving manufacturing to enhancing in-cabin experience and enabling predictive maintenance, AI is shaping the future of mobility. However, we still face challenges, especially with data privacy and regulatory policies. Moving forward, innovation in autonomous driving, IoT, and smart manufacturing will continue to drive the evolution of transportation, making it more connected and sustainable. AI-driven technology in automobiles is evolving rapidly, shaping the future of transportation. Let's look at the expected advancement in three phases: short term, medium term, and long term. In the short term, over the next 5 years, we will see significant improvements in advanced driver assistance system, making driving safer and more efficient. AI will enhance urban navigation and hazard detection, helping vehicles react to complex environments. Predictive maintenance will allow early detection of mechanical issues, preventing costly repairs. Additionally, AI will optimize vehicle manufacturing and design, improving efficiency and quality. In the medium term, within 5 to 10 years, full automation vehicles will become more common. With enhanced safety features, AI will integrate with smart city infrastructure, improving traffic flow and reducing congestion. AI-powered route optimization will allow vehicles to adjust routes in real time. Moreover, personalized vehicle features like adaptive seats, climate control, and biometric authentication will enhance user experience. In the long term, beyond 10 years, we can expect autonomous vehicle networks enabling seamless coordinated transport. AI will drive sustainability solutions, improving fuel efficiency and extending battery life. Self-healing materials will reduce maintenance needs. AI-powered intelligent road infrastructure will enhance safety, while blockchain-based security will protect vehicles from the side threats. This innovation will transform mobility, making it safer, smarter, and more sustainable. This innovation will transform mobility, making it safer, smarter, more and sustainable. Here we studied 30 research papers to complete our work. These are them.
Thank you so much, Dilshad.
And finally, this is. Thank you so much for your time.
Thank you so much. Are there any questions?
Yes, this
Yes, ma'am.
automobile. Now, have you touched upon this driverless
Yes, ma'am.
vehicles? You have given about the entire automobile manufacturing. You have gone into the manufacturing side. Have you touched on the driverless AI for driverless vehicles?
Yeah, at fifth generation, we have driverless manufacturing.
You told in-cabin experience. Is it related to driverless in-cabin experience?
Yeah, when it is driver become a passenger rather than driver. The passenger have in-cabin experience.
Okay. Means it's not driverless, no? That is related to manufacturing and the experience of the user. Okay. What about the AI-related manufactured vehicles with based on the quality of roads? Based on quality of roads, you have shown some dependency on high quality infrastructure, high quality.
Yeah. we can AI can involve traffic congestions and accidents and road infrastructure.
Road infrastructure, if the quality is not good, still it can go with the same
Yeah,
working.
yeah. This is an ongoing research.
Okay, thank you.
Thank you.
Thank you, ma'am. Thank you, Dilshan. Are there any other questions? Since there are no more questions, we'll be moving forward. I want to request Jeff and Sunny to kindly present his paper titled A Study on the Impact of AI-Driven Nudges on Financial Well-Being. Do we have you here with us, Jeff?
Yes, I am available.
All right. Kindly share your screen.
Yes, I will share the screen.
Yes, please.
Is it visible?
Yes, it's visible. You may start.
Yeah. Good afternoon, everyone. So I'm going to present the paper a study on impact of AI-driven nudges on financial well-being, and my co-author is Deva Jain. I would be presenting on based on our as a representative of our team. So coming to the introduction, we always relate financial well-being with objectives, but when we do the studies or when we come to the actual financial well-being, the financial well-being have two parts, objective as well as subjective. So in our study we have been finding out how financial well-being will be affected by various factors and finding out how an AI driven nudge can improve the financial well-being. So while looking into the Indian context, we have various schemes which would be including the increasing the financial inclusion. One of the example is Pradhan Mantri Jan Dhan Yojan, which was started at 2014 and created an impact like 549.7 million accounts, bank accounts, which mainly provided the formal system of banks to everywhere. So even though we have formal system of banks or formal inclusion to the financial system, a recent report by NCFE, that is the National Strategy for Financial Education, shows that only 27.18 percentage of Indian adults have adequate financial literacy. This shows that there is a gap between the financial inclusion as well as the effectiveness of the financial inclusion. So there is an opportunity for bridging this gap through by the AI driven nudges. So the concept of AI driven nudges. So the concept of AI driven nudges mainly come from the nudge theory, which has been explained in Thaler and Sustain in his 2008 the paper, where he has been saying that a nudge is an push which would alter the choice architecture of a person towards a desired behavior. So we are thinking why don't we give the paper focused on why don't we provide a real-time nudges to the customers or to the users of this, so that they would be taking the financially viable choices. So unlike traditional educations or the financial literacy programs, there are a lot of barriers in an human mind. We can say like cognitive bias, present bias, inertia, the lack of self controls. These are all barriers for the effectiveness of an financial well-being. So in the review of literature, if you look, we would be finding out that financial literacy is alone does not guarantee a good behavior, because there are various personal biases like cognitive and behavioral biases. So the reasons review of literature also mentioned the introduction of UPI has introduced like the impulsive spending among the customers. So this would be creating more. This would be pushing the people towards more low financial awareness and creating less financial well-being or financial advocacy for the people. So The AI-driven nudges has been a promising solution. This has been used in various domains, like in cybersecurity, in as well as e-commerce and recommender system. In cybersecurity, it has been given to the employees, where the employees would be given monthly nudges, which would be activating their system 1 and system 2, which has been explained in the nudge theory. As the system 2 is activated, they would become more cautious about what they are doing. So that would be preventing from malwares like emails, and it would help us to create more reliable cyber securities. And the next I would be telling about the objective and hypothesis. The objective of this study is to find out whether the AI generated financial nudges can impact the financial decision making behaviors. So the focus is specifically on the employed individuals in Kerala. So we have chosen Kerala because of particularly two reasons: the high household debt, that is 2 times more than the national average, and the low use of formal savings channel, that is only 35% from the total population. This has been mentioned in the recent NABARD report. So this behavioral pattern points the need for the intervention. So the hypothesis of our study is that whether AI-driven nudges has a positive impact on financial well-being or not. So we have used the OLS regression for this purpose. And the methodology, the quantitative, we have used a quantitative cross-sectional design. And the sample was 221 employed individuals from the Kerala, and convenient sampling was used. And we have distributed the questionnaire through the Google survey. And we have used OLS regression and with the help of Python. And we have also done the pre-test like VIF, residual analysis for the robustness. So the variables, so we have identified 6 variables from the review of literature. The paper is development and testing of comprehensive financial measures, where they have mentioned the 6 key variables which are the uh, affecting factors for the financial well-being. So we introduce we introduce the AI driven nudges also into this equation to find out whether the AI driven nudges has an impact on the financial well-being or not. So we have done a questionnaire, and we have circulated to the employees. So we have done the pre-regression test, or the pre-test which are very needed for to understand whether the data collected from the population is up to the mark for the research. So to measure the internal consistency, we have found out the Crohn's alpha, which is 0.76, which is says that there is an internal consistencies in the respondents. And we have also checked about the multicollinearity, where all the factors are predictors are less than 5. And to for the robust adjustments, we have done HC3 to remove the heteroscedasticity and improve the reliability of standard error, and the normality correction for the financial well-being, which would be done uh, by the log transformation. So we found, so we have done the OLS regression result. So we have created around like 3 models. The 3 models have, the first model is from the review of literature. We have taken the variables which are mentioned in the review of literature. And the second, we have done the model 2, where we have introduced the AI driven nudges. As we can see that it has a high significant impact, because the p-value is less than 0.05, and it has also improved the model's adjusted R-square, the model's the power for the prediction. So, and in the model 3, we coupled the nudge with that of the financial literacy, and we can see that there also these have been providing a significant improvement. So the key insight from these are these results clearly support our hypothesis that AI-driven nudges significantly improve the financial well-being. And the model from the model 1 to model 2, the increase of adjusted R square shows that it's more promising. And the model 3, which shows that the financial literacy amplifies the impact of nudges, which suggests that the people who may be financially literate are also struggling to have a better financial position because of various behavioral bias. So the AI driven nudges would be helpful to avoid these behavioral bias. So the implications of the studies. So as we have done a perception study, we can find out the implications of the fintech companies can be using this to improve their customer journey. Banks can be using this to improve their financial wellness programs. Like they can send the nudges to their customers for the repayment of debt, EMIs, and etc. And the policy makers can also be using this. The policy makers have already used the nudge for the retirement savings benefit, and we can also now we can hear the when we call someone, we would be able to hear the pre-recorded messages of the online frauds. These are all nudges which would be helping us to avoid from these problems. So the limitations of the studies are, we have done a cross-sectional design. There would be to draw a causal conclusion, and the self-reported data may introduce some response bias. The study is also limited to the employed individuals in Kerala, and we have been accounted for the other factors like external shocks like inflation, unemployment, or
Gentle
market
1 minute reminder.
yes, market downturns, which are very much affecting the financial well-being. So the scope for the future research would be to increase the scale of research and the ethical consideration of people, whether they want to accept the AI and manipulation at the yeah, like the privacy concern and the over reliance. So these are the references which have been taken. These are the sample references. We have taken more than around 20 references in our paper. So thank you. I'm open for questions.
What is
Thank you
this?
so much, Jeffrey. Yes, ma'am. Please go ahead.
What is this NABARD? You have shown in references also NABARD.
Yes, that is the National Bank for Agriculture and Rural Development.
Yes,
So
I have
these,
heard it. I have heard it.
yeah,
And the statistics what they are giving, state-wise they give it?
yes, they give it
Because
state-wise.
you mentioned in Kerala 35% only using the saving channels, and a household is more depth.
Yes, ma'am. It is more that.
And what is this nudge? You have explained something about nudge. What is
Yes,
this
ma'am.
nudge all about?
Ma'am, in simple terms, ma'am, we always, when we call somebody, and now in India, we would be hearing the voice of don't take calls for the digital fraud. We used to hear that. So that is a nudge. That is a nudge means that is telling our system. That is in nudge theory, we says that there is two systems, system one and system two. So when we hear this message, we would be becoming again cautious. That means we would be activating the system two. The system one is like, if I do a continuous work every time, we would be doing it in an automatically manner. So we would not be able to identify what all things we shouldn't do, because would be doing in a continuous manner. When we provide a nudge, so we activate our system too. So we would be having a clear concise that okay, now what should we do?
Reminder, like a reminder.
Yes, ma'am. Yes, ma'am. Like a reminder.
Okay. Thank you. Nice
Thank
presentation.
you. Thank you, ma'am.
Thank you so much, ma'am. Are there any other questions? All right. Since there are no more questions, we will be concluding this session with the last presentation. Yes, so that was the last presentation, and I sincerely thank all the authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chairs, Dr. Pankaj Chandra and Dr. S. Radha, for chairing this session. Here's a small token of appreciation for you, sir and ma'am, from the team of ICTIS 2025 and Global Knowledge Research Foundation. Thank you so much for joining us. I request you to kindly give the closing remarks and just share your feedback for the session with all the presentees here.
Hello, madam.
Yes, sir.
As usual, nice coordination, nice events.
Thank you so
Definitely,
much.
we as a session chair, as well as all presenters, definitely learn something. You as a ICTIS team, you are very punctual. And
Thank you so
definitely
much.
sorry from my side because of what I shifted my house, so that's why I'll
No
be
worries.
little late. So
No
this will
worries.
happen from my side first time. Yeah. So I again thank you for giving me this wonderful opportunity to work as a session chair. And congratulations to you and your entire ICTIS team. Thank you.
Thank you. Thank you so much, sir.
Yes, it is
Ma'am,
well
over to you.
organized. Yes, it is well organized. And the papers from various topics were also interesting. Thank you for the opportunity given to us for being the session chair. Thanks.
Thank you so much, ma'am. Thank you everyone for your valuable presence. Can I please request everyone to switch on their cameras for a final snapshot before I end the meeting? Can everyone please turn on their cameras? All right. All right. 1, 2, 3. Yes. Thank you so much. Thank you, everyone. Have a good day.